In the last chapter, we discussed about the if statements, where we added one deviation to the normal flow of the program. In this chapter, we are going to discuss the if else statement, which adds one more deviation to the program flow. So, if you see on the screen, this was the program which we discussed in the last chapter. We had S1, S2, S3, some three statements were there, and then we added one if statement to it. And because of this if statement, one more path was added to the program flow. If the condition is true, then the statement S4 was executed, which is result is equal to k into j. And if the condition is false, then this statement S4 was skipped and we directly came to the S5 statement. Even if this condition is true, then also after executing S4 statement, the control came back to S5 statement. Now let's add one more aspect to it. So far in the old program, we added only one deviation, one statement which executed only if this if condition is true. Now, what if this particular condition is not true? It is false. In that case, we need to add one more statement to our program flow using this statement, which is else. So if the condition is true, if j is equal to 3, then we execute result is equal to k into j. But if j is not equal to 3, that means this condition is false, then we execute the statement result is equal to 0. So if the condition is false, then the statement which are in the else block, they get executed. As you can see in this flowchart as well, if this condition is true, if the true path is set, then we are executing the statement result is equal to k into j. However, if this condition is false, then we execute this path and the statement S3, which is result is equal to 0, that gets executed. In our earlier version of the program, we initialized result is equal to 0 right before entering into the if statement. So that if the condition is false, we had already executed this particular statement. However, if we are using this if else kind of block, then we do not need to initialize result because this will be taken care by the else block. If the condition is false, then automatically this result is equal to 0 will get executed. Now from the condition we had two paths, one when the condition is true and one when the condition is false. If the condition is true, then we are executing result is equal to k into j. If the condition is false, then we are executing result is equal to 0. After executing all this if else block, then automatically our control will come back to the statement S5, which is print result. So it doesn't matter whether the condition is true or false, the statement S5, that is print result, will always get executed. And you know this because of this indentation. The statements which are indented here, they get executed only if this if condition is true. Similarly, these statements result is equal to 0, they get executed only when the condition is false because they are in the else block. However, if you notice the indentation of print statement, it is at the same level where the if or else is mentioned. So this print statement is outside of if else block. It always gets executed. So after executing S3 and S4, the control will come to S5. So this is how we specify our if else path in the program. Same thing we have mentioned on the next slide. In our program, we normally have some few statements before the if else block, and then we have few statements in the if block. We have few statements in the else block. So this suite of statement is outside of if else block, and S4, S5, S6, this suite, that is suite 2, is inside the if block, and S7, S8, S9, this is suite 3, which is inside the else block, And this suit 4, S10, S11 and 12, again it is outside of if else block. It always gets executed because it is coming in the normal flow of the program. Now let's discuss another variant of if else. So this you have already learned that we have if and then some condition. If this condition is true, then this statement is executed. If this condition is false, then this statement is executed. What this program is doing, if the given number is divisible by 2, that means if the number is even, then it is setting the flag to 0. If it is not even, that means if it is odd, if the num is odd, then it is setting the flag to 1. So this is what we have mentioned here. If number is divisible by 2, then the flag is 0, otherwise it is 1. This statement corresponds to the code written above. And I would say this statement, this English statement, is corresponding to the code. It is depicting what is written in the code, but it is not the way we generally speak in English. What we speak is something like this. We say that flag is 0 if number is even, otherwise it is 1, right? So this is our usual flow when we are speaking in English. Python provides us a construct through which we can write the code something similar to this. And what is that? This one. We say that flag is equal to 0 if number is divisible by 2. If num percentage 2 is equal to 0, that means the remainder of the operation, if num is divided by 2, if the remainder is 0, then we set the flag to 0. Otherwise, 1. So Python provides us a construct which is very close to the English language. And this is used when we are setting a particular variable based upon some condition. See what we are doing. We are setting the flag to 0 or 1 depending upon this condition, and the condition is whether number is divisible by 2 or not. Many a times you will encounter this kind of situation in your program where you need to set a variable depending upon some condition. If that is the case, you can very well make use of these kind of constructs. And the syntax for such construct is something like this. We have a variable is equal to one expression if the condition is true. Otherwise, we set the variable to expression 2. In our case, the first expression is 0 and the condition is num percentage 2 is equal to 0 and second expression is 1. And our variable is of course flag. So flag is equal to 0 if condition, that is number is even, num percentage 2 is equal to 0, else expression 2 which is 1. So this is how we specify our second kind of construct in the Python for if else block. There is a word of caution here. This is a general mistake which we do when we are using this second kind of construct. Let's discuss that as well before we jump into writing some program. Suppose we are given an example that we are we are given a number num is equal to 7 and we are asked to add 10 to a given number if it is even. Otherwise add 20 to it. And we write something like this. Num is equal to num plus 10 if number is even, else 20. Now if we compare this statement with the syntax which we discussed on the last slide, then the variable is num is equal to expression, first expression 1 which is num plus 10 if condition is true. So this is the condition. And second expression is just 20. So what will happen here is num will be assigned to num plus 10 if number is even, if the original value of num is even, Otherwise, it will be simply set to 20. But what was the requirement here? The requirement was if the number is not even, then add 20 to it. It was not that simply assign 20 to it. But what is happening in this code is we are simply setting num to 20 if the condition is not true, if the condition is false. So this is the mistake which is happening in this particular piece of code. How to correct it? Let me give you that example as well. So we should use expression something like this. Num is equal to num plus. Now what we want to add, that depends upon the condition, right? So we can make use of this parenthesis. So first of all, the expression inside the parenthesis will be calculated. And this expression is that 10, if the original value of num is even, then this expression value is 10, otherwise 20. And whatever comes out of this expression, this complete expression, that will get added to num. And this is what was asked in the question, that add 10 to the number if it is even, otherwise add 20. So num is equal to num plus 10 if number is even, or 20, right? So this is how we should use this kind of statement, this kind of construct in the Python. Okay, so let's move on to the next line. So far we have discussed only if and else. If condition is true, then we execute this suit, otherwise we execute suit n. So we had two paths in our program. However, this slide wants to say is that there can be multiple paths in your program. And how they are executed? We are given one if and then condition. So if this condition is true, then we execute this suit one. However, if this condition is not true, then simply do not jump to else part. Come to this particular part first, elif condition 2. So if condition is not true, then we first evaluate this particular condition. So if condition is not true, then try to evaluate condition 2. If condition 2 is true, then execute suit 2. If condition 2 is also not true, then jump here to this particular elif block and try to evaluate condition 3. And if this condition 3 is true, then execute this suit 3, and so on. Only if all the conditions mentioned here are not true, that means if any of this condition 1, 2, 3 and so on, they are not true, they are all false, then only you come to the else block and execute suit n. Let's try to understand through an example. Suppose we are given the machine speed as per this direction. If the machine is moving in north direction, then its speed should be 10. If it is moving in the south direction, its speed should be 15. If it is moving in any other direction, then the simply speed should be 20. Okay, so we write this kind of statement here. If direction is equal to north, then what we do is speed is equal to 10. We set the speed to 10. If direction is not equal to north, then what we do, we again check the direction by using this elif block. Elif direction is equal to south, we try to compare direction with south. So if direction is not north, then we are checking if the direction is south or not. There should be capital S here. If direction is equal to south, then we set the speed to 15. So first condition is checked here. Second condition is checked here. If direction is north, then we set the speed to 10. If direction is south, then we set the speed to 15. If the direction is neither north nor south, all the conditions have failed here. Then we come to the else block. And else block was if the direction is anything else than north and south, then the speed should be set to 20. So we come to this else part, speed is equal to 20. If direction is north, speed is set to 10. If direction is south, speed is set to 15. If direction is neither north nor south, then the speed is set to 20. Same thing is depicted in this flow chart as well. We are coming from our program, some previous statements may be there here, and then we are checking the direction. If direction is north, then what we do? Set the speed and come to the print. If direction is not north, this condition has failed, it returned false. Then what we do? Then we come to another condition, and here we are checking whether direction is south or not. If direction is south, then we set the speed to 15, and then again we come to this print statement, print speed. However, if this condition also fails, this condition has failed, then we set the speed to 20. And after setting the speed to 20, again we come to this particular print statement. I hope you understood by now that how this particular program is moving. It is having multiple flow of statements, multiple conditions being checked in one if, elif, and else blocks. Okay. However, in this example, if you notice, the first condition, this direction is equal to north, this is working on the variable direction. Second condition, direction is equal to south, this condition is also working on the same variable, which is direction. In this particular example, both conditions are evaluating the same variable, direction, but this is not the case always. The second condition, this elif condition, may be totally different than the previous condition. So these two conditions are totally independent of each other. The variables in these statements, in these conditions, need not be same. And this is what we are mentioning here, that the conditions in if and elif, they may be different. They need not be same. Let's try to understand through an example. Suppose we are given two numbers and we need to write a program which sets the result something like this. If both the given numbers are even, then the result should be 2. If at least one of them is even, both are not even, but at least one of them is even, then set the result to 1. If both are odd, then set the result to 0. So let's see how we can do this. So we are given two numbers, num1 and num2. So what we are doing is we are first checking whether the number 1 is even or not and setting it to into a boolean variable. So is num1 even? We are checking whether num1 is divided by 2. If it is divided by 2, then is num1 even will be true. If num2 is even, if num2 is divided by 2, then this variable is num2 even will be set to true, otherwise false, right? So this is how we set two boolean variable depending upon the value of num1 and num2. Now what our program requires? Program says if both the given numbers are even, then our result should be 2. So what we are doing here, if num1 even, if is num1 even, if this is true, as well as is num2 even is also true, that means if num1 is even as well as num2 is even, then we are setting result to 2. Now let's see the second part. If both are not even, Then we come to this elif block, right? And if both are not even, then we need to check whether at least one of them is even. Now, how do we check this? Through this elif statement. So here we are first checking this particular variable is true or the second variable is true. If any of these variable is true, you know this OR operator, right? The OR operator evaluates the expression to true if any of its operand is true. So if is num1 even is true or is num2 even is true, then it sets the result to 1. However, if both are not true, that means both the given number are odd numbers, then we execute this third block, which is else block, result is equal to 0. And here you notice that the condition in these two parts, they are not same. The conditions are different. However, in this example, they are still working on the same variables, but they need not work even on the same variables. They can be totally different. They are totally independent of each other, right? And in the last, we are printing this result. So whatever result is calculated here, that gets printed here. Okay, so this explains how we use if, else, and if elif statements, if elif constructs, if else constructs in the Python program. Now let's see these examples in PyCharm as well. So this was the first example which we discussed. We are given k is equal to 5, j is equal to 2. Now if j is equal to 3, then the result will be k into j. If j is not 3, then result will be 0. So if we try to execute this program, you can see the result is coming out to be 0 because j is given as 2. J is not 3, so result is coming from this statement, result is equal to 0. Now let's change this j to 3 and let's run it again. So let's run it again, and now you can see the output is 15. So if j is equal to 3, then the result is being calculated as k into j. K is 5, j is 3, so 5 into 3, 15. So now the result is being calculated from this particular statement. Right, so this was our first example which we discussed in the slide. Now let's move on to the next one. So next example was this: if the given number is an even number, then the flag should be 0, otherwise flag should be 1. So we are given a number, in this case the num is 8, and we are checking whether this number is even number or not by dividing it 2. So if this condition is true, then the flag should be 0, otherwise flag should be 1. Right? So let's try to run it this program. So num is 8. Because num is 8, it is an even number, so flag is coming out to be 0 because this statement flag is equal to 0 is executed. If we change the num to 9, we make it odd number, and we try to run this, we can see that now the output is 1. So this statement flag is equal to 1, this is being executed. Right, so this is the second example which we discussed. Let's move on to the next one. Here the same program we are executing through a different variant of Python. Now here we are setting flag is equal to 0 if this condition is true. If num is even, then we set the flag to 0, otherwise we set the flag to 1. And if you try to run it, we can see the output. Num is 8, an even number, so flag is coming out to be 0. If we change this num to 9, then again we are getting flag as 1. The same output, but we are using different variant of Python, different construct of Python. Let's see the next example now. So we discussed this thing which we would avoid while writing our program. So we are given a number. Now we are adding 10 to the given number if the number is an even number, otherwise we need to add 20 to it. And we discussed this is a wrong expression which is there. Why this is wrong? Because in this case, if this condition is true, then the expression which will be assigned to this variable is num plus 10. If this condition is false, then the expression which gets assigned to num is actually 20. But whereas our intention was different, we wanted to add 10 to the number if it is an even number, otherwise we wanted to add 20 to it. So let's try to run this program first. So we can see here now, because the number is an odd number, so 20 is being assigned to num. So num is getting the value 20, whereas what we wanted that 20 should be added to the original value of num. So what we should need to do is num plus and close the complete this expression in parenthesis, right? Now if we try to run this program, we can see that 20 is being added. We want to retain the original value of num, plus what we want to add to num is that depends upon the original value of 7. That is why we need to enclose this complete thing into the parenthesis. So 7 plus 20, because the original value of 7 is odd number, 7. So we added 20 to it, so num become 7. Let's try to change this num to an even number and run it again. Now you can see 10 is being added to num. 6 plus 10, 16. Now because num is even, so 10 is being added and the result is 16. Okay. So with this, we'll move on to the next example. And our next example was that we are given two numbers, num1 and num2. And what we need to do is, if both are even number, then set the result to 2. If at least one of them is even, then we set the result to 1. If both are odd, then we set the result to 0. So what we do, we are having two numbers, num1 which is 5, num2 which is 3. And then we are checking first whether the numbers are even numbers or not and setting the result into boolean variable. So is num1 even, is num2 even? These two boolean variables are set according to the given numbers. And then we are checking if both the numbers are even, that means if these two variables are set to true, then we are setting the result to 2. Elif, if this particular condition fails, that means both the numbers are not even, then we need to check if either of them is even through this particular statement. Elif, is num1 even or is num2 even? If this happens to be true, that means one of them is even, so we set the result to 1. However, if this condition also fails, that means both the numbers are odd, so we set the result to 0. And in the last, we print result. So in this particular example, we are given 5 and 3. Let's change it to 6 and 4. And if we run this program, we can see the output is 2. So which is correct. Both the numbers are even numbers, so result should be 2. Now let's change one of the number to make it odd number and let's run it again. Now you can see the result is 1 because num1 is odd and num2 is even, so result is 1. However, if I make num2 also an odd number and try to run it again, then the result changes to 0 because now both the numbers are odd number, so result is 0, and that's what we are printing here. Print result, so result comes out to be 0. So these are the examples which we discussed, and now we have executed the same examples in PyCharm as well. With this is the end of this particular chapter, and now you will be given some exercises. I would request you try to solve those exercises before moving on to the next chapter. Thank you very much for your time.